Hi everyone and welcome to my channel. Today we are going to be looking at functions and how we can use them to transform graphs. Here is a quick reminder of some of the rules we use when we are transforming graphs. I find that this table is very useful, so if you'd just like to make your own or screenshot this one, and you can use it to look at the rules when you're doing questions, and then hopefully by the time the exam comes it will all be in your head. This is the graph of y equals x squared plus x. We're going to call it f of x. Now say the question asks you to draw f of x plus 1. What this means is we are going to move the graph a units up. Now in this case a is 1, so we're going to move the graph 1 unit up. That means we're going to take every coordinate and we're going to shift the y coordinate up by 1. So for example, this coordinate is 1, 2. The new coordinate is going to be 1, 3, and so on. And we're just going to do the same for everything, and then it should shift our graph up. So here is the very poorly drawn graph of f of x plus 1. So that was an easy one, and let's look at some more. Example, I have drawn out the graph of f of x, and it's just a random graph. And let's say we want to draw the graph of 2f of x. Now if we look back at the rules, it says that af of x means a stretch parallel to the y-axis scale factor of a. Therefore 2 is a, and we are going to stretch this graph parallel to the y-axis scale factor 2. If we want to stretch parallel to the y-axis, then that means we have to multiply all of our y-coordinates by a, so in this case by 2. So I've just gone and I've multiplied all of our y-coordinates by 2 to get our new coordinates. Now you'll notice that this graph is steeper, but it is the same width because we haven't stretched it parallel to the x-axis, we've only stretched it parallel to the y-axis. Here I've taken the same graph, but this time I want to stretch it parallel to the x-axis. Now if we take a look at the rules, you can see that if we're stretching parallel to the a-axis, you have to stretch scale factor 1 over a. Now in this case a is 2, so we're going to stretch parallel to the x-axis by scale factor 1 over 2. Here is our new graph. I have multiplied all of the x coordinates by half, which is how I have obtained my new graph, and you'll notice it's more squashed than our original graph, and that's because we've halved its width. Now in my second example, what I've got is the graph of the cos function. Get from the graph of y equals cos x to the graph of y equals 2 cos of x. Remember, you're just doing this, and you can use the rules and you'll be fine. For the last question, we're going to be a bit more complicated. So we take the graph of f of x is equal to x squared. What transformations are used to obtain y equals 3x squared minus 6x minus 2? Well, this is just a transformation of this. There is a way that we can find out the transformations applied, but we have to write this in another format. Now if you know how to complete the square, then you'll be fine doing this. That's what we're going to do. So first you have to take the 3 outside. That is the first step. Next we're going to go on to complete the square for this. And we're going to take away the square of 1, followed by this. Which simplifies to this. Now this is a much better format because now we can find out what transformations were used to map x squared onto this. First of all, you look at this number and this number. This can be used to write the vector for the transformation. Now if we look back at our rules, then you'll see that this is basically, you're going to move 1 unit to the right, followed by -5/3 units down, as you can see in the rules. But that's not all. We have to take the 3 into consideration. So after we have translated the graph, this 3 is basically the same as 3 of f of x, which means we're going to stretch parallel to the y-axis, scale factor 3. And that is how you obtain that graph from this graph. But as long as you keep referring to this table and you keep practicing, then you should be fine. Thank you for watching. Don't forget to like, subscribe and share, and yeah, bye. At another example, here is the graph of the cos function. Let's say we want to apply a stretch parallel to the y-axis and a stretch parallel to the x-axis. How do we approach this? First, we must apply the function inside the brackets. So it says f of 3x. Looking back at our rules, this means we're going to stretch parallel to the x-axis with a scale factor of 1/a, or 1/3. This means we're going to multiply all of the x coordinates by 1/3. The old period of the graph was 360, and if we multiply this by 1/3, it gives us our new period of 120 degrees. This gives us the graph of y equals cos of 3x, but we want y equals 2 cos of 3x. So we're going to do the second step, which is to stretch parallel to the y-axis, scale factor of 2. We're going to multiply all of our y coordinates by 2. Originally, the maximum y coordinate was 1, and in our new graph, and I know it's poorly drawn, but in our new graph, the maximum is going to be 2. And so you have gone from this graph to this graph. So remember, yeah.